Okay, so next in research methods, and importantly, is maths. So mathematical skills can be up to 10% of the marks allocated on each paper. You need to be mindful of the fact that up to 30% of your marks overall out of 3 exams could be based on research methods or maths-based things. So first thing, look at page 23 of your booklet, fill it in and check that you are confident with the maths skills that are required, because there is some maths. It's psychology maths, but it's still maths. So first thing we're going to look at is data types. This can also be referred to as levels of measurement. So make sure when you see the term level of measurement, this is what it's talking about. So it's kind of different types of data. So you've got nominal, ordinal, interval, and ratio. So nominal, ordinal, and interval are more common. And then you've got ratio, which is a special type of interval data. So nominal data is quantitative. It's usually something that's that's been tallied. It's category, so it's a discrete thing. It's one or the other. So gender, weather, ethnicity, so on. So nominal data is categorical data. It's discrete data. Ordinal data is data that can be ordered. So first, second, third. This can be on a scale. It can be a subjective rating. So happiest to grumpiest person, so that could be ordinal data. So there's no fixed distance on the scale, but it is ordered data, first, second, third in a race. It's ordinal data. Interval data is data that sits on a scale with equal measurements, so it's standardized units. So for example, time, temperature, that's interval data. So data that's on a fixed scale. Ratio data is the same as interval data, but has an absolute 0. So for example, distance is ratio data, because you can travel 0 distance, but you could travel any amount of distance. So ratio. So nominal is discrete, it's categorical, it's usually tallied, yes, no. Ordinal is in an order. It's usually it will be scaled. Normally, it's in response to a questionnaire. So if you have a questionnaire, you tend to get ordinal data. Interval data is on a fixed scale, and temperature is a good example. Time. Ratio data has a fixed 0. A lot of the time, you don't need to worry about ratio data. If you just write it as interval data, that will be absolutely fine. So an inferential statistic is a way to determine whether a study has significant findings. You can generalize the findings to the population. So there are 2 types of statistic in psychology. You've got a descriptive statistic that describes the data. So measures of central tendency, averages, are descriptive statistics. Graphs are descriptive statistics. They describe the data. Inferential statistics are basically stats tests. You're determining whether the study's results are significant or not. In order to work out inferential statistics, we need to look at probability. So probability, or P, is the likelihood of something happening. Probability will always be a number between 0 and 1. 0 is an impossibility of something happening. 1 is a statistical certainty of something happening. So your probability will be a number between 0 and 1. It is calculated by looking at the number of particular outcomes based on the number of possible outcomes, and you will work out a probability of something happening. So it's the likelihood of something happening. It's always going to be a number between 0 and 1. In psychology, psychologists tend to use a probability of less than or equals to 0.05. This means that the probability of the behaviour happening again is equal or less than 5%. So finding is significant if there is a probability of kind of 5%. If you get a result that's higher than this, it could still be significant, but this is the level that psychologists look for. In an exam question, if you see a level of significance that's not 0.05 or 5%, the question was probably going to be asking you about an error. So it's worth bearing in mind. You don't need to learn about the other levels of probabilities, 10% or 1%. But if a question asks you about a different level of probability, the question probably wants you to answer about an error, which we'll come to shortly. So 0.05 or 5%, that means we're 95% sure that something's happened, and there's a 5% chance that something hasn't happened or something's gone wrong. Psychologists can and do use other levels of probability. So they tend to use a 1% instead of a 5%. You cannot necessarily determine proof in psychology unless you are completely sure that something has happened or hasn't happened. So it's important when you talk about probability, what the probability level suggests is that it suggests significant support. It doesn't prove anything. You can't prove anything unless you're 100% sure. So it shows support for a theory. It doesn't prove a theory. Just watch your wording when you're answering some questions. Errors. In psychology, you have a likelihood that you could make an error. You've got type 1 and type 2 errors. A type 1 error can be called a false positive. A type 1 error, what happens is we reject a null hypothesis incorrectly. So by mistake, we reject a null hypothesis. So that's a type 1 error, false positive. A type 2 error, a false negative, is where we accept a null hypothesis when we should not have done. So type 1 is a false positive, type 2 is a false negative. If you make your significance level stricter, you reduce the chance of making a type 1 error, but you will increase the chance of making a type 2 error. So a type 1 error tends to happen when significance is not as strict as 5%. So if you're looking at 10%, you tend to get a type 1 error. A type 2 error tends to happen when the significance is too strict. So you use 1% instead of 5%. So type 1 error, false positive, is where you incorrectly reject a null hypothesis. And that tends to happen when the significance is too lenient, so 10% instead of 5%. A type 2 error is where you incorrectly accept the null hypothesis, and this tends to happen when the significance is too stringent or too strict, so you use 1% instead of 5%. So these are errors. To reduce the chance of both errors, you can increase the sample size. What's good about the 5% level of significance is it minimises the risk of making an error. So a 5% level of significance is used because it minimises the risk of making a type 1 or a type 2 error. Within inferential tests or statistical tests, there are some tests that are called parametric tests, and there's some tests that are called non-parametric tests. So we will learn different tests, and some of those tests are parametric and some of those tests are non-parametric. So 3 of them are parametric and the rest of the tests are non-parametric. A parametric test is a more stringent test. It has to have at least interval level data, so that's a fixed scale. It needs to have a normal distribution, so it shows a normal distribution curve. It cannot have a skew, so positive or negative skew. You can't have that in a parametric test, and there's no variance in the sample, so you tend to have a small spread in the sample. So parametric test is more stringent. It's done on interval level data, data that doesn't have a skew, that has normal distribution, and data that doesn't have a large spread. The 3 parametric tests that we use are Pearson's, a related t-test, and an unrelated t-test. So a Pearson's test is a parametric test that looks for a correlation. A related t-test is a parametric test that looks for a difference with repeated measures designs, and an unrelated t-test is a test that looks for a difference with an independent groups design. So those are your 3 parametric tests. So Pearson's for a correlation, related t-test for a difference with related data, repeated measures, or matched pairs, an unrelated t-test for independent groups, and a difference. The other tests that we look at are referred to as non-parametric tests. So non-parametric tests are used on nominal data and ordinal data. If you are looking at nominal data, you will use a chi-squared test if you have an independent groups design. and you will use a sign test if you have a related design or a repeated measures design. So those are tests of difference. A test of difference on nominal data, you either use chi-squared for independent groups or sign test for repeated measures or matched pairs. If you have a test, a correlational test, you will use Spearman's. So if that's for ordinal data, you will use a Spearman's test for a correlation. If you have ordinal data and you are looking for a difference, you will use a Mann-Whitney test if you have independent groups, and you will use a Wilcoxon test if you have related data, so matched pairs or repeated measures. So nominal data, it's chi-squared and sign test. So those are both tests of difference. They're both on nominal data. Chi-squared is for independent groups. Sign test is for repeated measures. If you have ordinal data and it's a correlation you're looking for, you use a Spearman's test. If you have ordinal data and independent measures design, independent groups, it's Mann-Whitney. If you have ordinal data and repeated measures, it's Wilcoxon. And those two tests are used for a test of difference. This is a flowchart that you can use to decide what statistical test you can use, and it's something that you need to learn. You need to know the different tests. You need to be able to decide in an exam what test you might use. You will never have to calculate the values of any of the tests apart from a sign test. You'll never have to do them longhand, but you need to know when they would be used, and you need to know why they would be used. So you could be given an example and you could be asked what statistical test would you choose, and you would name the test and then give your reasoning for choosing the test, and the reasoning is in this flowchart. Or you could be given the name of a test and you could be asked, why is this test used? And again, you just put the reasoning from the flowchart in for your answer. So have a look at page 36 to 46 of your booklet, pause this, and then try and work out what the appropriate test is, whether the results are significant or not, and what conclusion you can draw. And the answers will be on the following slides. If you haven't paused it yet, I'm going on to the answers. Okay. For the parametric tests, here are the answers. And those are the answers for the non-parametric tests. You also need to be aware that there are some statistical formulae. You need to know what they mean. You don't need to calculate any formula yourself, but you need to know so sum total, the bottom left, N is your number of participants, O is your observed value, E is your expected value. So just go back through your booklet, check that you understand the maths, check that you understand the statistical formula. Peer review is a process in which research goes through before it can be published. It's where experts in a same or similar field review a piece of work, and they look for any errors in the work, and they look for any mistakes in the work, they look for any plagiarism in the work. So the aims of peer review is to allocate funding, to validate research, to check it's good, to check it's relevant, and then to suggest any amendments or improvements. So those are the aims of peer review. Reporting on investigations. When research is written up in a journal, it's written in a standardized form. There are 8 kind of sections of a investigation of a journal. You need to be aware of the different sections. And you need to be aware what might be in them. So the first thing is the title, so that is the title of the journal. The second thing is the abstract. The abstract is a paragraph that sums up the rest of the journal article. The point of it is to save you reading a whole journal article, you can read the abstract and see what goes on. So the abstract will include a sentence from each of the other sections. The introduction will include background research, it will include aims, and it will include hypotheses. So that's what's in the introduction. The method will go through methodology, materials. It will allow replication of a study because you'll know what happened. The results, describe the results. So they'll include descriptive statistics, so averages, graphs, They will include inferential statistics, the stats tests, and statements about significance and probability. A discussion will conclude the research and discuss what was found and any problems and any mistakes, and suggest future research. The references is a way to list any other journals or any sources that were used in order to write that report. And the appendices is where you put raw data and graphs and anything that you don't want in the final write-up. An investigation is written in the past tense, and formal language is used throughout. Have a look in your booklet to see more details from each section.